Assalamualaikum. Hello everyone, let me introduce myself. My name is Martin Chandradinata with my student ID number is 44432306165. I am a student at Sultan Ageng Tirtoyasa University, Fisheries Science. Then I will talk about my summary from the journal entitled Advancement in Fish Vaccination, Current Innovation and Future Horizon in Aquaculture Health Management. So, aquaculture is growing industry that provides an affordable source of protein, but it faces significant challenges from infectious diseases that cause substantial economic losses annually. Vaccination has emerged as a key method to combat these diseases and reduce the reliance on antibiotics, which can lead to antibiotic resistance and harm fish immune system. The development of effective fish vaccines relies on a true understanding the fish immune system, which comprises both innate and adaptive immunity. Innate immunity provides a non-specific defense through cycle barrier and chemical responses, while adaptive immunity generates immunological memory against specific pathogens. Vaccines work by exposing the fish as to attenuated, non-replicating, or inactive pathogen or their subunits, stimulating an immune response and antibody production. Um, While a significant progress has been made in fish vaccination with over 50 vaccines available for more than 13 fish species, challenges remain. These include issues with administration efficiency, vaccine degradation in aquatic environments, and the need for further research into oral tolerance and the fish immune system. And here is a summary of current advancements and challenges in fish vaccination. Bacterial disease. Point 1. Edwardscellosis caused by Edwardsia pesticida. This disease is a major concern due to antibiotic resistance. While there are no commercial vaccine available, research is focused on leaf attenuated and subunit vaccines. Point 2. Bacterial kidney disease caused by Renibacterium salmoninarum. This chronic infection in salmonids has only one commercially available vaccine, Renogen, which show variable immune responses. Point 3. Clavobacteriosis or columnaris disease caused by Clavobacterium species. This disease results in significant losses. Existing vaccines include Aquavac, called Verivac 1 and Verivac 2, but more research is needed on their efficacy. Point 4. Furu, Furunculosis caused by Aeromonas salmonidea, Salmon, Salmonidea. This high-mortality disease has several available polyvalent vaccines. Through mineral oil adjuvant vaccine, while protective, can cause adverse reaction. Viral disease. Point 1. Koi herpes virus. This DNA virus causes significant mortality in crab (Ozoganos). Inactive vaccines are used and DNA vaccines are under development. Point 2. Infectious hematopoietic necrosis virus. This RNA virus has patented vaccines, but commercially availability is limited due to safety concerns. DNA vaccine trials are ongoing. Point 3. Red Sea Bream Iridovirus, a DNA virus for which a formalin-based vaccine exists, but a bivalent or polyvalent vaccine is being considered for border protection. Parasite disease. There is currently only one commercially licensed vaccine for parasitic infection against sea lice. This is due to limited understanding of the fish immune response to parasites and their evasion mechanism. Research focused on DNA and subunit-based vaccine administered via intraperitoneal injection. Then a point of challenge and limitation. Point 1. Administration efficiency. Oral vaccines are preferred for their ease of use and reduce stress on fish, but they can cause oral tolerance, suppressing immune responses. Mucosal and immersion vaccine also face efficacy and dosage calculation challenge. Point 2. Long-term immunity. The need for repeat handling and anesthetic producers for injection-based vaccine highlight the importance of developing vaccines that induce long-term immunity. Point 3. Cost efficiency. While vaccination is generally cost-effective, production a strong vaccine involves significant expense from antigen isolation to commercial evaluation. Point 4. Efficacy data. More scientific papers are needed to compare the efficacy of different commercial vaccine protection against the same pathogen to help farmers make informed decisions. And the last point is fish size limitation. Vaccine often cannot be used on fish weight less than 20 grams, leaving larval and prion stage, which are most susceptible to disease outbreaks and unprotected. Then, despite this challenge, advancements in fish immunology and vaccinology are leading to improved vaccine formulation, diverse administration methods, and the development of cost-effective polyvalent vaccines that protect against multiple diseases with the single injection, contribution to the sustainability of aquaculture and global food security. Enough for me. Thanks for watching. Sorry, my English is bad. Thank you.